Okay, so this lesson is 6.2, solution of linear systems in 3 variables. So in the past, we've been only solving linear systems in 2 variables. This time we're going to be dealing with 3 variables. So we're going to start off by first kind of identifying what 3 variables looks like. So remember, if it's a system of 3 variables, not only do we have a x, y, but we also have a z. So this is kind of the three-dimensional world, which kind of looks like this picture right here. If you kind of imagine this is your z-axis. This is no longer your y-axis. X and y are two-dimensional, remember? So this is our x, and this is our y, laying in the same plane as though we had a piece of paper, right? If we could kind of imagine this as like a piece of paper floating around here into space, flat, and then the z plane kind of going through it. And so your xy is now laying flat down on a piece of paper. Okay, so I'm just going to erase that and get it out of the way for the moment, because I really want to just show you what those three-dimensional points look like in space. You will not be asked to graph things like this, but just so that you understand what this ordered triple is. Again, you have your y-axis here, and you have your x-axis here, and then your z-axis kind of comes right down through the middle. And so if I were going to graph the ordered pair -2, I would go -2 on my x, and then maybe -2 on my y. So that would be here. So I would go -2 in this direction, and then -2 in this direction. It would put me right here, just about, right? -2 back, and then -2 up the y. And then let's say I'm going up 4 on my z. 1, 2, 3, 4. So then this would go up 1, 2, 3, 4 units. And so I'm dealing with this point kind of hanging out there in space, backward 2, forward 2, and now up 4. Okay? And these are some situations that you can have when you're solving these. Okay? You can have one solution. So you have 3 planes that meet in just this very one point in the middle. Okay? You can have infinitely many solutions, meaning these 3 pieces of paper are kind of working themselves around in a circle, and this line is all the points that they have in common. They all share that line. And then last is an infinite many of solutions, meaning that all 3 planes lie in the same plane. So they're basically stacked on top of each other. Okay? No points in common are when your planes are parallel. So anytime you're dealing with parallel, it's no points in common. This one has no points in common because these 2 planes are kind of parallel to each other. And then this one coincides with the blue plane here, but doesn't coincide with the orange plane in the same spot. So they don't all 3 correspond in the same place. Neither do these, and then also neither do those. Okay? So if we're solving a system, let me just erase and scroll my page. If we're solving a system, there are, of course, all those situations. So we're going to start off by talking about how do we solve a system in 3 variables, and then I'm going to use this example just below it to explain to you how to do that. So the first step is to eliminate a variable. Great, if I could spell right. Eliminate. Okay, eliminate a variable from any 2 equations. The second thing you're going to do is eliminate the same variable. So eliminate the same variable from 2 different equations. Okay. And then you're going to eliminate a second variable from the resulting equations of number 1 and 2. And then you're going to substitute back through. So let's actually do this using the example at the bottom of the page. So you're going to look at these and you're going to ask yourself, which variable would you like to eliminate from the equation? And so remember, with elimination, we like to look for zero pairs because they tend to eliminate pretty easily. That means that they have the same coefficients and one is positive and one is negative. So right now I'm looking right here at these two z's, right? Those are going to be easy. If I add them together, they're going to simplify. So my first step is going to be to take the equation 2x plus y minus z equals 2. And the third equation, x plus y plus z equals 2. And I'm going to add those two equations together. And that's going to give me z eliminated from my equation. So now I have 3x plus 2y equals 4. That's my first step. Okay? Now, that was step one, eliminate a variable from any two equations. Now I have to eliminate that same variable from two different equations. So now I need to eliminate the z from two different equations. So you can use, since we used 2 and 3, you can use 1 and 3, or you can use 1 and 2. But you can't use 2 and 3 again. Okay? So my second step is going to be to take the first equation, 3x plus 9y plus 6z, equals 3, and use it with the second equation, 2x plus y minus z equals 2. And in order to get them to eliminate, this one needs to have a 6 in front. So I'm going to multiply that whole second equation by 6. So my top equation is going to stay the same, 3x plus 9y minus 6z equals 3. And the bottom equation, once I distribute the 6 among every single item, is going to say 12x plus 6y minus 6z, sorry, this is a plus up here, equals 12. Add them together. The z's are a zero pair. So I get 15x plus 15y equals 15. So step 1, check. Step 2, check. Step 3, eliminate a variable from the resulting equations. So these are my resulting equations. 3x plus 2y equals 4, and 15x plus 15y equals 15. And so now I need to get these equations to eliminate in some way. And so if I multiply the first equation by 5, then these are both going to be 15s, and that's awesome because I want them to cancel out. But I want one to be positive and one to be negative. So I'm going to multiply this one by negative 5. So I'm going to get negative 15x minus 10y equals negative 20. The bottom equation is going to stay the same. And when I add them together, these are zero pairs. 15 minus 10 is 5. Negative 20 plus 15 is negative 5. Divide both sides by 5. Y equals negative 1. So now I have one of my three variables, okay? And so the directions say substitute back through. So that means we're just going to keep working our way back up through until we get to the end. So when you have one variable, it's not going to make any sense to plug back in here to one of the original equations because I still will have two missing variables, and that's not helpful. So I'm going to take this y equals negative 1 that I know, and I'm going to go back to one of the two resulting equations where I only have two variables. That way I can solve for one of the other variables. So I'm going to do 3x plus 2 times that negative 1, which I know y is equal to, equals 4. So 3x minus 2 equals 4. Add the 2 to both sides. 3x equals 6. Divide by 3, and I get x equals 2. So again, now I know two variables, and I can go back to one of my original equations and solve. So I'm going to use the bottom equation because it looks pretty easy. 2 plus negative 1 plus z equals 2. 2 plus negative 1, or 2 minus 1 is 1, plus z equals 2. Subtract 1 from both sides, z equals 1. And now I know my ordered triple, so I put them in order. X is 2, y is negative 1, z is positive 1. So this is my answer to that problem. That means that this point out there in 3D space satisfies all three of these equations. Okay? So that is how to solve a system in 3 variables.